Thanks everybody for attending this version of the Center for Applied GIS virtual seminar. We're lucky enough today to have with us Yuri Potawsky from Esri, located here in Charlotte, and coming to us virtually from somewhere high above the earth. Yuri, just a brief bio. Yuri got his master's at App State. And are you originally from North Carolina?
I am. I grew up in a very little Lenore, up in the northwestern corner of the state. Yep.
Beautiful town, beautiful part of the country, and
Yep.
App State. And then you took yourself to the big city to work for the Department of Defense in DC.
Yeah. So I was up there for about 3 years. Yep, against the U2. So yeah, that was a previous life. But yeah, doing a lot of remote sensing stuff, a lot of imagery analysis, and raster analytics stuff. Yep.
And now that you're back here, you're doing all kinds of things, and I really look forward to your presentation today, where it's sort of like the ultimate GISer a la carte menu, where we're going to talk about dashboards, machine learning. It looks like a bunch of different pieces, and we'll have some time to open it up to our audience, and they can ask you some questions, because there's a lot that you are good at here. So without further ado, I'll hand it over to you, Yuri. Thank you so much.
Yeah, thanks, Doug. Living up to that description, I don't know, but I'll do my best. Can you all see the screen that has the Three Rivers dashboard on it? This screen where I'm cursing, my cursor's at. I'm seeing some head shaking. Yeah. Okay, cool. Okay, awesome. So I think what I'm gonna do is actually me just start with a with kind of a real quick presentation, and then walk through those dashboards. I think is the best way to do that. I do disclaimer up front. I do love to talk, so if you have questions, or feel free to interrupt me as I go along here if you have questions, and if not, we can hold those until the end. But yeah, so thank you for having me, Doug, and thanks for the introduction. And so my name's Yuri. I am a solution engineer at Esri, and kind of what that entails is we have a business development arm of the organization, and so we're responsible for working with state and local government, council of governments, any municipality you can think of, and we are the sales arm of the organization. And what's unique about my position, though, is I sit with sales, but I'm a technical resource for that sales team. So like numbers and finance and stuff, I don't deal with that at all. Mine is mainly working with our technology and doing presentations and proof of concepts for organizations. So just a little bit about what I do. And today I want to talk kind of two areas. I'm going to talk a little bit about dashboards, and then I'm going to switch over to something a little different and talk about machine learning. That presentation is a little bit lengthy, so I think what I'll try to do is just hit the highlights, and then if you have any questions, I'm happy to provide the slide deck afterward. And some of these are on my GitHub account, so I'm happy to pass that information along, so you can just download that if you're interested. So when we talk about dashboards, when in the Esri perspective, we're talking about a single screen of information. So you open a web browser, it's a very high level view, it's a bird's eye view of an example of a workflow or something you're trying to geographically explore. So I think the example I could provide that we're all really familiar with is probably the Johns Hopkins dashboard, right? I think everybody in the world has seen this dashboard. They were recognized at the UC for their work, and this is the example of when I talk to friends and family, they are familiar with this dashboard. Trying to explain to them what GIS is, not happening, but if I can just show them this dashboard or what a dashboard is, this seems to really resonate because it's been out in the news, and so this is the example that I would give of what a dashboard is. It's a single page. We have some charts and graphs. It's all powered by a map. But a lot of times we get caught in this, you know, it's a display with charts on it. I mean, it just depends on what your description is. And in my mind, I'm going to talk a little bit about usability and what the user interface looks like and all of that. But I think there are a few key points. So making a dashboard effective, because I think a lot of times when I work with customers, I'm in my mind, particularly this morning, I was on the phone with someone and they were talking about stormwater, and they were asking, well, I have a decision maker that needs to know the age of this infrastructure and these assets. And I think it varies greatly how that information can be conveyed, because I think like the dashboard that we're looking at right now, it's a power outage dashboard for the kind of the Southeast. And it's very good at conveying one point. What are the customers without power, right? It has a number, a ticker, or a time window as to what that time frame is, what the states that are applicable, and then it's powered by that map showing, obviously in Alabama, those states, those counties that are red, they have more folks without power. So I think that's one thing you have to keep in mind. You have to communicate that information at a glance, because if you overcomplicate things, then people start to go to sleep. They're not really absorbing what you're trying to portray. So that is something to keep in mind. So it's a science and an art, I would say, working with dashboards, more so than anything else that we, as a company, that we make or that we provide software. I love this this picture, right? So in the tech world, we have all these, a lot of times I have these like really grandiose ideas of what something needs to do, how it needs to portray something, and you know, X, Y, and Z. I got to have this chart, I got to have this diagram, and we have to have 50 elements to portray what we need. But oftentimes this is exactly what happens, right? You have an idea on the left, the beautiful sidewalk with the curb cut, and that's accessible, and this is what you think they're definitely going to use my dashboard this way. Well, more often than not, they're going to use it in a way that is conducive for them to get the information out of it that they need. And that's a really delicate balance between too much information and too little information. So see this everywhere I go, people cutting corners. So that's I think that's kind of funny, but that describes it in a nutshell. And I won't go too far into this design theory. There have been volumes of books in the UI UX world written about you know, designing websites and single page sites and information sharing. But I think this point is important. As a user, you often perceive things that are aesthetically pleasing. That is a product that's more usable. So just keep that in mind if you're going to be designing dashboards. And I'll show some. I don't want to just talk through slides. I only have, I have 17, but we'll zip through these, and then I can actually show some examples of what I find are dashboards that present information well and have usability. And when we're talking about configuring dashboards, this pyramid, this graphic is a little bit, it's a little bit nuanced. I would like to clean it up a little bit at some point, but basically, if the experience increases to like a significant experience, and so in my opinion, the John Hopkins dashboard, that is a significant dashboard because it displays a really significant geographic event. It's easy to navigate. It's although the topic is not, I would never describe COVID as enjoyable, the experience for that dashboard or some of the others, they're very enjoyable. It's easy to navigate. It's easy to find stuff and query. So that's something that's really important. And then on the flip side of that, we have kind of those objective characteristics that we need. Is it functional? Is it reliable? Does it scale? I'll talk about that. And how usable is it? And that last bullet, technical level. So when you're pushing something out for the public and you don't know, I'm sure everyone on the phone is very technical, right? And an experience for you is going to be completely different than an experience for my mother, right? Like it would, the Johns Hopkins dashboard is something that she could navigate and use, but that's your audience and their technical level is like really critical, particularly with dashboards. One more corny graphic I'll throw your way is this idea of a remote control, right? And so, and the corresponding examples. So we have, your basic, my TV remote looks like the one on the left. It has a volume button and an on-off switch. And this dashboard is really good at presenting whatever these events that it's trying to present. But you can't do a whole lot with it. It's a visual. You can't really query it. You can't do any kind of you can do visual analysis on it, but it's very basic. And then we just kind of move up from there. The one in the middle, much more information, does a pretty good job at presenting that information. And then on the far right, that dashboard kind of gives me a little bit of a headache. I think it's very, very dense. I think like the graphs at the bottom, my suggestion would be to just have tabs for each one of those, and then you could just scroll through those instead of having them all presented on the same page. And again, kind of at the top and the bottom there, as the flexibility of the application increases, there's just an inverse relationship with usability. So far left, very usable, not flexible at all. Far right, very flexible, not very usable. And there's a trade-off there, because I think like on the dashboard on the right, I don't know that, I don't know how much utility that dashboard really has, I guess. So real briefly, I'm going to talk about just the types of dashboards, and they fall traditionally into two cans. You have snapshot dashboards and then monitoring dashboards. So if you're, and I'll show examples of those, both of those, but if you're monitoring some type of phenomena, like we do a lot of stuff with like real-time data, and I'll talk about this a little bit in the machine learning stuff. That is more aligned with the monitoring style. So there's going to be frequent updates. People are going to be looking at that. You might have a stakeholder that opens that dashboard at 8 a.m. They get a good snapshot or picture, excuse me, shouldn't use the word snapshot, but a picture of what the morning is looking like, or what's transpired over the evening hours. And then they may look at that again 50 times throughout the day. If you're just doing a snapshot dashboard, they may just look at that in the morning, and then it might be days before they look at that again. It's non-updating data, so it's more data that's more stable, doesn't change that frequently. And this is kind of two divisions that we internally reason with about dashboards, but I mean, they don't have to fall in one of the, you could have one that does monitoring at the web map level, and then some of the data is static. I mean, it doesn't, obviously it's just kind of what the use case is. So to author dashboards, and I don't know how familiar everyone on the call is with creating dashboards or with interacting with them, but they're all powered by a web map. So the square one, when you, in ArcGIS Online, you create a dashboard, or in Portal for ArcGIS, you create a dashboard, it starts with a web map. That is what the dashboard is built off of. Now, that doesn't mean that you can't have ancillary data that complements that web map in other elements, and I'll go through those, but that is the basis. So finding out what question you want to present and maybe what kind of question you want to answer is very important. And when you create that web map, all of the symbology and the colors and the styles that you're using, that's all transferred over to the dashboard. And that is all really, really important when you start out. I won't read through all of this, but it just basically, you need it to highlight the workflow or what you're trying to convey. These are some of the elements. So won't read through all these either, but these are the, and this continuously updates. I feel like the product teams, it's like every week, you blink your eyes and there's something new that's been added, or something that's been done that enhances the usability or the product as a whole. And so these were, at the time of writing a couple months ago, these were what we had in the landscape for dashboards. And I mean, they run the gamut, like embedded content. If you wanted to embed a website, you could do that there. If you wanted to create a pie chart, which I'll show, that runs off of some feature service, that's where it would be located. And then there's elements that you can arrange, like your headers and your side panels, but that's more for like aesthetics that we were talking about. Does a dashboard need to have all these elements? Absolutely not. I don't think I've ever created a dashboard for anybody, state or local government, that has contained every single one of these elements. Not to say it can't, but I often find that, again, it's that law of diminishing returns. Won't really talk about this. This is built into the product for mobile dashboards. It's just, ensuring that if the majority of users are consuming through a tablet or a mobile device, that design should be something that you should keep in mind through testing. But I mean, won't really go into that in too much depth. And so a few of the things that you can do with an interactive dashboard. So think of a website. You log on to a website, you click on something, and JavaScript launches a modal window into the middle of the page and prompts you or asks you for a question. What's your location? Or do you want to sign up for emails or notifications, whatever the situation is. We can do a lot of the similar things in dashboards. And let's say you have that first one, an event. Let's say I drag a map and I'll show you that. The dashboard can interactively update. So if I select a location, all my graphs update. It's not just static. Same thing with actions if you're doing a filter or any of these other map actions. And that's all defined through the service. But what's cool about that is it doesn't edit your data at all. You're just running a query, you're just viewing. So all the stuff that's powering the dashboard, no issue there. They can also evolve with time, right? Charts might need to change as data accumulates. So in this example, the month of May, okay, we had 1 month, one frame or time frame, a reference of data. Then we have July, and then we go into 2021. But then, oh wow, we have an entire year's worth of data. So being able to update and reflect that in your dashboard is important. Because a lot of these charts start to get a little busy and very challenging to understand. Already discussed this, and I can pass along again the slide deck, but there's a whole doc on building scalable dashboards. Obviously, that was important for this one because they were getting millions of page hits a day. But that's just important for anyone that's creating a dashboard, particularly that has a lot, that is very data heavy, has a lot of data, a lot of manipulation. So in summary, real quickly, a dashboard grabs attention, communicates information, and at a glance in a split second, and really helps you spot stuff that's the most important. And this was kind of a laundry list of documentation that I threw together that has a lot of websites and links on configuring dashboards, how to set them up, and on down the line. So I'm happy to share that.
Yuri, if would
Sure.
you be okay if we broke up your presentation and just polled the group, see if they had any questions?
Yeah, totally. That's fine.
Anybody have any questions about the cool stuff we've seen so far?
Yes, thanks for your presentation. I have a question.
Sure.
So I'm wondering whether we can embed it, the dashboard to a web page and make interaction between the dashboard and other content on that web page. For example, I click on a table on that web page, and then it will filter the data, the feature layer or charts in the dashboard.
Awesome question. Fantastic. So basically, you can embed the dashboard in any website. I mean, that's if it's shared publicly, it's just a single URL that it resolves to. It's just like any other web application that we make. However, like the interactivity, you know, the interaction between content on that particular website or that page and the dashboard, we don't really have a mechanism for doing that through dashboards, but we do have another product called Experience Builder.
Yes, I
Yeah.
tried that. Yes, that one use a URL parameter
Right.
to do the filter. But I'm thinking, is there a way that I can, for example, I create a web page using the Experience Builder, and is there a way I click on a table on that web page, and the URL parameter changes itself automatically?
So there is a way to do that.
Mhm.
But it's not out of the box with just the default Experience Builder. So there's actually an Experience Builder SDK. So that is, it's just like a web app builder for developers, if you're familiar with that.
Mhm.
It's basically an SDK that you install, and then you can build that interactivity. You can definitely do that. I mean,
Oh.
I've seen people do it before, have some experience with myself, but out of the box, you know, through ArcGIS Online or Portal, the Experience Builder doesn't have that particular functionality, because like you said, it's a URL. It's yeah, but it's
Right.
doable. Yep.
So is the URL parameter the only way that it can make such a interaction?
I would think so, because it's referencing that feature service on the back end. So yeah, that would be the only way I could think of off the top of my head that you would be able to get that interaction to happen, because it would have to send some type of request to that service so it updates in the dashboard. Yeah.
Okay,
Yeah.
thank you.
Yeah, of course. Great question.
Thanks for the question. Any other questions? I have one.
Sure.
When we're trying to put this sort of content out there, I guess as part of best practices is that you try this on a group before you make it available for prime time. Is there any quick guidelines that you would recommend in sort of beta testing this, or are there any sort of metrics that you would look to that would tell you that you were doing a good job or not doing a good job?
So we do have some, and I don't know if I put them, I'm looking at this page of resources. I don't know if I put that in here. We do have some design documentation that there's nothing per se to, like with ArcGIS Online, we have a lot of things for like security, right? You click a button and it checks if your security is sound. We don't really have anything that does like an automatic, check like that. But my suggestion would be, I think you kind of hit the nail on the head, Doug. I think what I would do is I would create one. I would see internally what the response to that is, because a lot of times, and I'm just speaking from my experience with government, someone will create one, and the perfect example is that picture of cutting through the grass when there's a sidewalk. They'll create this dashboard and they think, oh, it looks awesome. The GIS department signs off on it. They're like, this is great. We're going to put it into prime time. And then it gets out on the website, and or it gets to the public domain, and people are like, this is too challenging to use. We don't understand what message this conveys. How do I interact with this? So I think I cannot overstate how important it is to kind of ground truth that information on the back end before you do that. We do have a lot of like documentation on creating them, what we think from a usability perspective looks good or is good, but nothing that I can think of that kind of, well, this should be arranged this way. But I think a lot of times for me, looking at what people have done before is really helped guide me. And a lot of the solutions, I don't really want to go down this wormhole, but through ArcGIS Online, we have a lot of solutions. If you're familiar with those, for public safety and the environmental, the environment and government. And a lot of those already have dashboards that are pre-configured. So a lot of times what I've done is I've deployed a solution and I've used that dashboard as a template, because then I can copy that template And those are really good at portraying, like if we're talking about monitoring birds, which is what this dashboard does here. There's a specific template that people have done before me that is conducive to portraying this information. And so I think that would be where I would start personally. That was kind of a roundabout, but I hope that helped.
No, that's great. It tells me two things. One is our sort of seat of the pants decision to circulate it internally is a good one. And it also tells me that there may be some practitioners out there that would like to come up with those metrics, dwell time, how many people hit on certain things that you want them, to hit on, download, stuff like that.
Yeah,
Okay.
and unfortunately through dashboards, we don't have like the ability to bolt up like Google Analytics or some type of analytics capturing software, but through Experience Builder we do. And so you can capture all those kind of those page clicks and interactivity and stuff like that. So that might be something to explore.
All right. Well, thanks
Cool.
for accommodating that, and feel
Sure.
free to move on to your next topic of interest.
Okay, awesome. So these are just some dashboards I wanted to just real briefly show that I think are really well laid out and do a really good job of like portraying information. So this is a crowdsourced data set through this volunteer organization and through City of Minneapolis. And basically they're just trying to capture information on bluebirds. And I think what this dashboard does really well is there's a map there, but it's not the absolute focal point of the dashboard, because I think dashboards, while they're powered by that web map, I think a lot of times the actual analytics and the data that powers that web map is just as important. And so I think this is just a really awesome example of, it's not too busy. I feel like it's there. It's walking a fine line, right? But I think it does a really, really good job. And also what I like about it is it does a lot of the counts by the sheer number and also by a percentage. And it presents that information in two different mediums, right? One as kind of like a bar chart histogram, and the other as a pie chart that's interactive, that shows you all of these different metrics. I can also query by a location, which I think is really critical. So if I select Silverwood, which is the one right in the view, there's no data. Let's see if I can get to one. Interesting. Might be because I'm in a view. There we go. Yeah, but I think it does a really good job. It has the queries built in. You can select species. You can select a whole number of things, and the dashboard interactively updates. So I think that's a really good one. This is one that I would see when we were talking about the remotes. This is probably on the far left. But it does one thing really well. It presents the information about stream gauges from the USGS. And so we can see that it updates as I interact with the map. Back up to my old stomping grounds, there's a couple stream gauges here, but it has those listed, and then it actually has the numbers that are experiencing flood conditions. This is historical data. This is not current. So I think this does a really good job. The map is not busy. It's super streamlined. It's just the hydro layer and a shaded base map. So I think it does a really good job as well.
So this is really the front end of a ginormous geodatabase, as all things are, right?
Yep, this is consuming data through the USGS API of stream layers. Yep, so they have a huge repository of Streamgage data that updates interactively, and yep, this is just referencing a layer that they've published from that data source. Exactly. And the last one I wanted to show before I kind of moved on to the machine learning piece was this wildlife sanctuary program in kind of the northern tip of Virginia, right at the Maryland and West Virginia borders. I think this does a really good job of portraying a few things. So total protected acreage, and this has to include like national forests and national park land. They have a counter for that sheer number of acreage that's protected. But then what they do is they drill down into a few of these counties. If we look at those counties, so I think there's 7 counties here with Loudoun having the most. It shows you what are those counties that have those certified acres and what is the total acreage per geographic unit. Talks about the property count by county. I think also kind of going back to the dashboard where I was talking about, it shows it in percentage and sheer number. I think this is awesome because it shows the count by year, but also the count by county and the count by type. So 3 different ways of presenting similar information. But we can see that residences are the sheer overwhelming majority at 91% of properties that are in this sanctuary program. So I think this does a really awesome job. It also has the ability to interactively update, and you can, so the dashboard updated, it showed the properties that were in the year 2013. You can actually specify a specific date. So I think this is really streamlined, does a really good job. I think the base map looks fantastic. So I think this is a really good dashboard in my opinion. So I had a few others, but I think in the essence of time, I'm going to pause there. If there are any questions on this, happy to answer those. I'm also happy to pass these along, but I was going to kind of shift gears. I don't know. We have till 2 o'clock, right? Or should I? Okay. Okay. So let me shift gears here. And so I'm going to I'll try to fly through this, but not, not talk really fast, because this is a pretty large topic. And this is actually it's kind of an iteration of a presentation I've given before at NCAUG last year. So I've kind of taken that and kind of reworked it. But yeah, so I'm going to talk in this kind of second portion here about geo artificial intelligence in ArcGIS, and not really talking about Skynet yet, not talking about the Terminator. Maybe, one day I'm sure it will be there, but which is terrifying. But for now, what we're talking about is feeding a GIS information and that GIS learning from that information and helping you to make decisions about geographic data. That's how I would describe Geo AI. So a few things. How does it complement GIS? And so I'm a longtime user of like the raster analytics tools, and I learned on desktop 9.3. That's where I started, on to 10.9.1 that we're currently at, and those tools, particularly for raster and imagery and big data, have changed dramatically in that 14-year period. And so that's one thing I want to address briefly. And then how to get started. I think this was kind of like a few years ago, this was just like a glimmer, a thought in the back of the development team's eye. They were like, man, we would really like to get to a point where we could push this out to every technology piece that ArcGIS or Esri has. And I think that time has come. So it's much more accessible. And then lastly, there are a ton of requirements for doing these type of analysis, but it's an accessible technology. Now, if you had asked me 5 years ago, I feel like that would have been a very different response. But now it is much easier to access the data and access the functionality that AI brings to us. So, before we get to this, running stuff in Visual Studio here from my screenshot, I want to talk a little bit about the background and how this workflow can be applied for your organization, whatever you're studying, things that you're interested in, whatever your research is. I feel like it can run from A to Z, regardless of what you're studying, whether that's urbanization or the natural environment, I feel like it can contribute to everything. So in this holistic large arena, we have artificial intelligence. So basically what that does is it allows a computer to mimic human intelligence. This has been around for decades. This is just like when you're in Amazon and it makes a suggestion, or you're on Google and you do a Google search and it makes a suggestion about what it thinks your search term should be. That's artificial intelligence. Machine learning. The machine improves at given tasks with experience. The more it runs, the more data you feed it, the smarter it becomes, and the more exact and correct decision it can make based off of that data and the iteration. And now we're kind of in this deep learning realm. And so basically machines train themselves using deep neural networks. A neural network is just a tree of yes, no, pass, fail tasks. And some of these might be, and I've got an example, I mean, these might be hundreds of networks deep, but the computing technology really hasn't been there until, the last 5 to 10 years to be able to do this at scale. So briefly, the top inputs program results, that is any input, any program you interact with. So when I created this PowerPoint, I had an input, I had a program, and I got a result, the slide deck, right? So what artificial intelligence tries to move toward is this middle section. You have inputs, and let's say they're images for land cover, and I'm trying to extract building footprints. I provide it parameters, which in order to operate within, I feed it into some algorithm, it makes predictions, creates labels, and tells me I'm 95% certain that this is a building. I'm 95% certain that this is a car. And then what you get is an abstraction of this inputs model results. So this is what ArcGIS does for you. You don't have to wade through all of this middle ground and understand the algorithms, and those are academics that are doing that, like yourself. So way over my head. But the computer kind of abstracts a lot of that away. Why is machine learning important now? We have tons of big data. We're able to leverage GPUs at like the desktop level. Like my laptop has a GPU. I run a ton of machine learning tasks on my machine. There's a huge community of developers and academics that are working on these projects. And again, neural networks. I'm gonna skip over that. So you're like, yeah, Yuri, this is great, blah, 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 but what can I do? What can I achieve through using Geo AI? So these are some of the examples of projects that we've done internally. So the upper left is hard to see, but there's a space-time traffic accident trend. So we can actually take that traffic data, leverage a model based off of time, dates, historic traffic information, real-time traffic information, and we can build a prediction surface or a prediction model about where there's a high likelihood that there's going to be accidents at certain times of the day. In the lower left corner, it's really hard to see, but this screenshot right here is actually from Charlotte Water, and we worked on a project with them where they have a camera mounted on the roof of a truck, and they were like, these solid waste drivers and these water meter techs, and they drive these routes constantly, and they're just going all over town, and it seems like, can we just figure out some way, since they're going to be driving the vehicle, to capture information at scale? And so what they did was they slapped the camera on the roof of the truck. It has an integrated GPS receiver. It goes around and it takes 360 imagery, and there was a model trained. Myself and a few other people, we went around, in images, we labeled water meters, and then we fed that into the model, and then the model, like I think the success rate, when all was said and done, was like 98% success for capturing water meters from just these handheld images. I think it was like a savings of like $500,000 a year by just leveraging that technology. The other screenshot there with the exit 359 sign, that's another use case. DOTs oftentimes leverage this. They're driving down a road and they need to do a sign inventory. You can actually train the model to grab that. It will attribute the GIS with what kind of sign that is, what text is on the sign, and do that all automatically. And some other examples of like traffic counts at a stoplight, identifying cars, using Lidar data to extract power lines and trees. So there's a whole host of things that organizations are doing. One that comes to mind is Washington, D.C. wanted to inventory all of their crosswalks. And so they were had access to some leaf off imagery, and they were able to grab like, I don't know, 95% of the sidewalks through ArcGIS in an inventory, instead of sending out, you know, individuals into the field to capture that information. Obviously, there's a ground truthing component to that, but it's pretty cool what you can do. And so this is how it's historically worked in ArcGIS. You know, you have imagery, raster, point data. You prepare that data, you process it, and you analyze it. That's exactly how it works now. You have a neural network, and this is a really great example. We have a picture on the left, and what it does is it breaks down, it identifies those edges, combines those edges, identifies features, and then we get George Washington's face as an output, right? And this is done, and you can see all of the nodes and how the linear line work connects to those nodes. It's just, that's what's so complex. It's just so GPU intensive. And so now we're finally at a level where we can kind of leverage this technology. Not going to talk about that per se, but a little bit about the deep learning experience. So it sounds very challenging, right? When I talk to customers or clients or anyone for that matter, they're like, man, this sounds like some, you know, science fiction. I need to have a PhD in analytics or in you know, an AI to do this. Yes, if you want to know the ins and outs of the point CNN network and what algorithms it's running on the back end, yes, being a mathematician, you probably need to be a mathematician, right? Or a statistician. But those models are already there. And I think what's interesting is, you know, my suggestion is just to use a model that you think fits and then just do multiple iterations. If it's not, you're not seeing the results that you think you should, I'm sure there's another model that's better suited to that specific task. So it's always the same route. You create training samples. Are you guys, Doug, is everyone using Pro now, or are we using a combination of desktop or Arcmap and Pro? What's the?
We're sort of all over the place, but we tend to be focused on desktop and haven't migrated so much to the cloud-based GIS services.
And is it anyone?
Go
ahead, I'm sorry.
We use Pro, yeah.
I think you use Pro?
Okay. Yeah, I was just curious. Thanks for that information, because all this is Pro-based. And so you would just label those objects. So for instance, if I'm doing a land cover classification, I'd have imagery. I draw polygons around those units that are important to me, impervious surface, woodland, you know, forest cover, maybe you have some open water, whatever the situation is. You draw object, you create those, just like very similar to the Arcmap experience. You label those objects, you export them for deep learning, and then you can run an analysis against that using a model in Pro. And that gives you a model file, and then that just goes into one of those tools there, either if you're detecting objects like discrete objects like vehicles or houses, or if you're doing a land cover classification, that would fall into the classifying pixels division. And so this is kind of the broken down chart. You'd label those. Go ahead, sorry.
Yeah, I have a question. So I'm wondering, I have not used deep learning in ArcGIS Pro, but we do have some research using deep learning. For example, we we use the deep neural network to do the semantic segmentation for point cloud data. I'm wondering what is the role that ArcGIS Pro play in terms of implementing this deep learning algorithms, and can we use some other I mean other algorithms instead of some default networks in ArcGIS Pro?
Yeah, totally. Great question. I am actually gonna hit on that. That's a great point. Yeah. So currently in Pro, you're very limited at what algorithms you can select, because in our mind, well, in the product team's mind, they're trying to make it as easily accessible to a majority of users, right? They want you to be able to have a button click experience through Pro. But no, you can totally, and I'll show that. You can totally do this in Python, and you can use any model that you want. Yep.
Okay,
Yep.
sure.
Yep.
Thank you.
Yeah, of course. Yeah, and this is just kind of that workflow: labeling, training the model, running the analysis, and then outputting data. Just kind of rehashing there. And so this is the pro workflow. I decide, what kind of imagery I need, or in the point cloud classification, what's the density of the Lidar data that I need? What are those considerations? I would make that determination, and then I would create those training samples through the image classification toolbar, and then I would train the model, label the objects, train the model, and then use the model. And so that relies on the PyTorch backbone. So you can't, there's not a whole lot of configuration that you can do there, to your point. The second thing, though, that I would point out is there is a Python-based workflow. And so there are any library that you want to leverage that is supported. And so this is done through Jupyter Notebooks. I don't know if you're familiar with that, but yep. So, and Jupyter Notebooks have actually been onloaded into Pro, so you can create notebooks in Pro. But the majority of the time, I have a local install of Jupyter Server, and I'll just do this stuff in raw Python, leveraging whatever framework I want for that. Because a lot of times, like scikit-learn is a perfect example. I'll use it for some things, but there are just some tools that aren't there that maybe another library like Keras has, or whatever the situation is. So that would be my suggestion would be to try it in Jupyter Notebooks. And we have, I don't know if I included that here, but we have an entire sample library of Jupyter Notebooks that you can kind of customize and tweak to your example. And we talked about that briefly. For Pro users, there's some dependencies through pip or whatever, Anaconda, whatever your Python manager is. Those need to be installed. The same for Jupyter Notebook. But this is a really good, I think this is the slide I wanted to show to that point. So you can leverage ArcGIS Pro for interactive creating the samples, but you can also use the ArcGIS API for Python, which has a module that's specifically created for doing deep learning. And what's cool about that is you can kind of mix and match. If the Python API doesn't have what you need, then you can use an open source library and kind of bolt for lack of a better term, a solution together to do that. But it all is the same, regardless of what way you're doing it, whether you're doing it in Pro or you're doing it through Jupyter Notebooks in Pro or just Python. You always have to label objects. You have to train that model on that labeled data, and then you can use that model. I think this is the last. I had this slide and one more, I believe, and then I'll wrap up. But this was just an example of like some tree identification, a real quick model that I used to train images, handheld images of tree species, and using just Python and some Python libraries, and then some of our tools to identify trees. And I got really good results with this. This was just something I tried, and got really good results kind of using some of the default tools in Pro, in a combination or in concert with Python, some of the more advanced analytics capabilities. But there's a whole host of really cool stuff you can do with it. Yeah, so I feel like I've sucked all the air out of the room here, but yeah, I appreciate you having me and listening as I kind of went through this, and I went through that quickly. But
well, it's very exciting, especially how easy it is to use, how we could be doing this today if we aren't already. Before Yuri goes, any questions out there?
Yes, I have a question. So I still did not see what role ArcGIS Pro play in the deep learning implementation of deep learning. Is that a tool in this case to prepare the training data, or?
it is, yeah. So this is actually an Arcmap, a screenshot from Arcmap right here. But this is Pro. Yeah, so you would use Pro to create the training sample data. So you have you'd use Pro to create the training sample data, and then that's where you kind of have a fork in the road. You could either use a series of geoprocessing tools with as we discussed, that kind of limited number of Python backbones to do the deep learning, or you can take that training data, you can export that, and then you can use any framework of your choice in Python. Yep.
So does this support point cloud?
It does. The most current version of Pro supports point clouds. Yep, for doing training. Yep.
Oh, okay. Okay. Thank you.
Yep. Yeah, of course. Awesome. Well, yeah, if there are no questions, I'm happy to give you guys back some time here.
Any other questions, guys? Yuri, thanks so much. Really appreciated, and a nice presentation. I could see a lot of work went into that.
Yeah, thank you. No, I'm happy to. I love talking shop. These are, particularly the AI stuff, is really something that I support a lot of customers with, and so I'm always, I love talking about that that kind of technology piece. So yeah, always happy to present on these things, near and dear to my heart. So
well, very good. All right, well, let's have an applause for Yuri, and thanks so much for visiting with us. And
thank you.
For the Cages based group, we're almost done, but we have to make sure that we have all our boxes marked and ready to get moved out on the 21st. And for everybody, if I don't see you before then, have a great holiday.
Thank you.
Yeah, thanks for having me, and have a great holiday, and good luck with finals if you're in that I remember those days, so good luck if you're in that crunch right now. So
all right, take care.
Take care, everyone.